All right. So okay. So you see example like this. So you're invited to develop a system that can automatically classify a given leaf. So in this application domain, there are only two types of leaf as shown by figure 8 and 9. Okay, so propose of features to be used and explain the way to differentiate. So you have type A and type B. So how should we differentiate the two?
High frequency, low frequency, sir.
Yes, in this case, the two image has different surface. One smoother surface, another one a more coarse surface. So in this case, you can use the frequency transform. So what we do is we use the spectra features. Okay, the more specific name for this frequency features, we call it spectra features. So we know texture of A is smoother compared to B. So A has lower frequency, lower power in high frequency component, right? So just like here, you can see that. So in this case, you can see the high frequency. If we go into B, type B, I choose number 7. You can see that most energy focused dekat mana? High frequency region or low frequency region?
Low.
So mostly dekat biru sini kan, low frequency region. High frequency pun ada tapi they one only out of 4. So if you compare, you check, analyze dia punya composition ya, only 13% falls in the high frequency. Majority are in low frequency. So in this case, you can conclude, okay, so this is type yang smooth, all right, which is B. A, higher frequency, all right. So, okay, let me choose a high frequency, let's say number 3. So if you go number 3, then you'll find that this one, the high frequency region actually has equally same as the low frequency. So in other words, a lot of high frequency, a lot of power dekat high frequency memang banyak lah. So then you can conclude, okay, the image is high frequency type lah, which is coarse lah. Okay. So you get the idea, basic idea. Okay. So the texture, what we do here is we transform the image to frequency domain. So this is what we do, transform to frequency domain. So we have the dia punya the coefficient. We find the coefficient for each of the basis image. Then after that, compute the ratio between the total power and the highest frequency. So this is the highest frequency. So we group all this as high frequency. So then from that ratio, we check, compare the two ratio. The one with lower ratio is A. Okay, lower ratio meaning that the frequency percentage of high frequency is low. So in this case, 50% high frequency for the type A. Kalau type B, kalau saya ambil 7, type B, you can see that dia punya composition less, 13% only. Just now, the one of higher frequency, 50%. So from this, the checking on the ratio of high frequency over the total energy, then it can give you an indication whether it is coarse or smooth. Boleh ikut ke? You get the idea?
Yes, sir.
What about the rest?
Yes, sir.
Yes, sir.
Boleh?
Okay, sir.
All right. Right. So you can play with this example later on. All right. So this is where you can enter the number. Okay, which pattern you want to choose so that you can see what is the transformation, the results of transformation. Okay, so that you don't have to do it manually. Okay, right. So that's basically about the spectra features. Next, I have yet to satu lagi questions, which is how to differentiate. Yes. By using edge detection, describe briefly how to determine a round object from a square object. So remember when you do edge detection, Sobel, remember Sobel? You
Yes,
calculate
sir.
the edge direction. Remember you calculate the edge direction. So so how do we differentiate a round object from a square object based on the edge direction? So kalau square object ada berapa edge? How many edges are there? A square object.
More than
Square object, how many edge?
4.
Yeah, 4. So how many directions are there? 4 juga kan? 0 degree, 90 degree. Okay, 270 degree, 180 degree, and then 270 degree. What about round object?
One direction.
You go. Round object one direction. Round object the other direction ada boleh ada. Let's say this is the round object kan. So dia boleh ada 0 degree, boleh ada 45 degree, or the 90 degree, 135, 180, banyak kan? Are you following?
Yeah.
So what we do is we try to kira dia punya statistics lah. Okay, distribution of dia punya each direction. So kalau square object, dia akan nampak dia ada 4 major direction, yang 0, 90, 180 and 270. Tapi kalau round object is distributed over all direction, dia semua pun ada. Kalau triangle dia ada berapa direction? How many directions are there for triangle? Triangle. How many directions are there?
3.
Yes, exactly. If it is triangle, then it's 3 directions. So that is how we can use edge detection, and particularly the edge direction to differentiate shape lah. This is the basic shape. Tapi for more complicated shape macam mana? So basically we divide the image into different parts, and then we try to ambil dia punya statistics lah. All right. So like for example, a human will tend to have a head which is more of round shape, and then body which is more on rectangle. So that combination will gives you hints. Okay, ini adalah human punya body, something like that lah. All right. So that's how we make use of edge detection, and then go up further to differentiate shapes, and not only basic shapes. Actually, you can combine and go for. I nak tunjuk MATLAB ni. Can actually go for dekat lab manual. I think until lab 3, lab 4. Quantization 5. Okay, edge features. Okay, if I try to run this, huge transform, alamak, sorry. So this is what I want to show you. So if you try to tabulate or you find a histogram of all the edge point. So in this case, you detect all the edge point here, right? And then you try to find their edge direction. And then you try to find the histogram, the distribution of all the edge direction. So you'll find that all the edge direction is equally distributed. Okay, we have those between 0 to 45, 45 to 90, 90 to 135, and to 138, dia lebih kurang sama aja. But if rectangle, what happened? How many major directions are there? Hello? Ada berapa direction dekat sini?
4.
Yeah, 4 major direction. Okay, if triangle, how many are there?
3.
3, exactly. So 0, 1, 3, 5, 270. So this is how we try to describe the shape in terms of numbers, because eventually computer is only can interpret number. All right, so for us, we see shape like this. But for us to describe shapes in terms of number, this is how we describe. We calculate the edge direction, and then we try to tabulate it in form of histogram. So this histogram, different shape will be shown in different histogram. So then we compare the histogram, all right, and see how similar it is. So this is how basically we try to describe shapes using histogram of each direction. Any question?
No, sir.
The concept is simple, but of course to do the actual implementation, these are all the codes inside, including what you learn. Okay, the upper 4 degree, kalau dia between 270, 360, so what you need to do is you have the plus 360 and plus what? Remember the one that I mentioned to you in the class? Yang pasal the 4 quadrant tu? Remember this thing?
Yes.
Yes.
So this one actually is coded here. All right, so if it's less than 0, so this one, they are under which quadrant? The third quadrant. So then you have to add 180, add 180. So kalau dia ni less than 0, greater than 0, this is second quadrant. So add 180 is same like this. So these are all the codes which you can take a look. But of course, kalau you rasa, you just roughly take a look lah. The details sangat tu kalau tak faham is okay. All right. And then when we go further, adalah we use that actually to create the histogram of the distribution of each direction. And then from the distribution, it will basically help us to differentiate the basic shapes. Okay, and then once you can differentiate basic shapes, so for more complicated shape, then we take it as it's a combination of all these basic shapes. So then we try to, from a big image, we divide into smaller sub-image, and then for each sub-image, we calculate separate, dia punya separate histogram, and then we use that to describe a more complicated, a more complex shape like human and so on. Okay, so this is called a histogram of each direction. All right. So for exam, usually we'll ask you how to differentiate a round object and a square object. Then this is how you can answer lah. So square will have 4 major directions. This will have round object will have direction distributed over all direction. Okay, so I think it's already 50 minutes. Okay, let me stop recording. How to